All right, the question was, go.
28.
All right, let's take a look at 28. All right, yeah. Again, I am a little, I think I'm a little upset with the book, how they do things as far as, you're supposed to remember a squared plus b squared equals c squared. True? All right, because again, this is a what? This, because they're diagonals, they are perpendicular. Do we agree with that? All right, it's a rhombus or a square, so the diagonals are perpendicular. And it said, if I'm not mistaken, that WT was 3. So this right here is 3. All right, so then this is just a squared plus b squared equals c squared, which is 9 plus 9 equals c squared. So c squared equals 18, so c is equal to 3 radical 2. You have to know that. All right, you have to know that. You have to know all the radical stuff. All right, that was a good question, actually. All right. Someone else on any of the work from yesterday, as far as just figuring out the angles and the sides. Yes. What does 16 say? We didn't do that. Yeah. All right, here we go. All right, so let's everybody take a quick look at 25. Okay, so BDA. So let me find BDA, which is this angle right here, correct? All right, now remember, a rhombus is unique because the diagonal actually bisects the angle. Right? Everybody agree with that? It bisects the angle. So if I said ABD is 24, then what is ADB also? 24. There you go. 24. You with me on that? Because opposite angles are congruent, right? And because it's a rhombus, this is equal to this, so it makes an isosceles triangle, so it will have to be 24 also. Yes, ma'am. 26. So now I need ACB. I need this angle right here, correct? ACB right here, right? Well, you have to remember, if that's 24, that's 24, right? This is 90 degrees. So 24 minus 90. You agree with that? All right. Lots of different ways. There are so many ways to figure it out. All right. That's what I'm saying. It doesn't matter to me how you figure it out. Anybody else? Anybody else? And again, I'm just telling you, it's just knowing the rules. I don't think it's that hard. Anybody have any questions with that? All right, so now let's just go ahead and start working. What? Okay, we have one more request for 24. Uh-oh, went too far, I think. All right, let's look at 24, CP. All right. So let me erase this so I can just double check everything. All right, so PB is 12. So this right here is 12, which also means this is 12. And if AB is 15, right? A squared plus B squared equals C squared. Right? So in this case, it's 15 squared is equal to x squared plus 12 squared. Right? 225 is equal to x squared plus 144. And then, what is that? 81 equals x squared, so x was 9. Right? Okay. All right, let's go ahead and get started on the other stuff. Let's finish it out. And notice what I tried to do is I just tried to draw everything out for you. All right, so I think it would be easier for us to do. All right, it says, given each set of vertices, determine whether the parallelogram is a rhombus, a rectangle, or a square. All right, now notice it says list all that apply. Because if you are a square, you are a what? A rectangle, and if you're a square, you're also a rhombus. All right, so you have to know those facts also. So here we go. Let's start with number 5. So everybody graph those out for me. So 1, 2, -2, 1, -4, 4, -1. This looks like a what? Yeah. Now we know it has to be at least a what? Well, if it's a square, then it's automatically a rhombus, right? So what I'm looking at right here, guys, is this is what I'm looking at. From here to here is a diagonal, right? From here to here is a diagonal. The diagonals look what? The diagonals are perpendicular, right? So if the diagonals are perpendicular, then it is at least a rhombus. At least a rhombus. Would I agree with that? So now, I would want you to write that. Diagonals are perpendicular. All right, the diagonals are perpendicular. All right. Then the next thing we can do is we can just do the slope of the side. Would I agree with that? I think that's the easiest thing to do. All right. So let's look at this. So, wow. This one I went from here to here. So that slope looks to me like what?
1.
Slope equals 1. Right? Because I went up 3 and over 3. And then over here, here to here, everybody agree that's what? We agree it's -1, right? And then the slope over here is 1. The slope over here is what? -1. All right. So now we know the sides are what? The sides are perpendicular, right? Do you agree? Sides are perpendicular. So because it's perpendicular, now we know that it is a what? A square. All right, we know it's a square. Everybody okay with that? Yeah, I don't think that's that bad. All right. So if it's a square, so we would say it's a square, a what? Rhombus. Is it a rectangle?
No.
Is it a rectangle?
Yes.
Every square is a what? Rectangle. But every rectangle is not necessarily a what? Everybody okay with that? Because the definition of rectangle is just opposite sides are equal. And consecutive sides are perpendicular. Anybody have any issues with that? All right. So let's just do number 6 together. -2, -1. -1, +2. Wow. Anybody else plot it like that? Does it look like a square? A rectangle? Yours kind of looks like a rectangle. Mine does not. Now, it's definitely not a rhombus, though, right? I mean, I didn't do that bad a job plotting it. All right. So let's just see what we got here. So this slope right here, this slope of this side is up 1, 2, 3 over 1, right? Then this slope here, down 1 over what?
5.
Is everybody else getting that? So slope here is negative 1/5, right? So now we know it's not a what? Square or a what? Square or rectangle, right? Remember, in order for it to be a square or rectangle, the slopes have to be negative reciprocals, right? Come on, guys. Right, that's not really hard. So this is none, right? None of them. Now, if I go down 1 and over 5 here, this slope is negative 1/5 over here, right? 1, 2, 3, and this slope is 3. So it's just a parallelogram, right? It's a parallelogram. Rhombus, the sides are equal, right? Sides are equal. That's definitely. I'm not even going to check that. All right, I'm happy with that. All right, let's go down. We did that proof. All right, let's check out 13. All right, let's see if we can do this proof. WZ is parallel to XY. WX is parallel to X or ZY. And then WZ is congruent to ZY, right? And I'm trying to prove that that is a rhombus. I think this is kind of easy. All right, but I definitely need some help. So let's go ahead and put this in. All right, given. All right, so is this a parallelogram?
Yes.
How do I know it's a parallelogram?
Opposite sides are parallel.
Opposite sides are parallel. You okay with that?
Mm-hmm.
All right, now, all right, so I want some help here. I don't want to do it. I want you guys to tell me. All right. So somebody come up with a thought. All right, we're trying to prove that it is a. We're trying to prove that it's a rhombus. Right, that's parallel. All right, the reason I'm moving that down is because it's kind of in the way. All right, can everybody see that now? All right, come on, someone tell me. What do we want to do to prove this is a rhombus? All right, Jackson, what? Say what? ZY is congruent to. Why is that? No, that's okay. It's a good start. Tell me. Opposite sides of what? Yeah, opposite sides of A. Well, the problem is I said something to it first. I shouldn't have. I should have just let you guys tell me. First thing, it is a what? You got to say it's parallelogram. All right. So step number 2, we're going to say that W, X, Y, Z is a parallelogram. All right. Now, why is that, guys? Yeah. You don't have to write definition. I'd much rather you just say opposite sides are what? Opposite sides are parallel. And that's a symbol for parallel. So it is a parallelogram because opposite sides are parallel. Everybody good with that? Now, Dalton, tell me. Bless you. WZ is congruent to what? XY. And you would just say opposite sides of a parallelogram are congruent. Okay? So now what else can we say? Go.
That ZY is congruent to WX.
ZY is congruent to WX. Yep. Opposite sides of parallelogram are congruent. Okay, so now what can I say? Say it. Good. And what's true about all of them? No, not the angles. What's true?
WY bisects.
No. We're talking about sides now. You guys, I think we're almost there. What are we saying? Yeah, we would say all sides are congruent. Now, of course, we're not going to write all sides are congruent like that, but we just said, look right here, guys. Didn't we say WZ was equal to YZ? And WZ, so let's write this down. So WZ is congruent to ZY, and ZY is congruent to what? WX, and what else? YXY. You're correct. YXY, because we said WZ, right? So I'm trying to show you this is all just one giant what? Substitution. Everybody okay with this? So now we proved all the sides are congruent. Substitution. So now we can just say that what? Yep. I would say that's true. Come on, guys. I don't think that was that bad, right? All right, let's try the next one. Let's take a look at 14. Okay, there's a lot going on here. I'm trying to prove that it's a square. All right, so here we go. Okay, so it says angle QPR is 90. Q and TR is congruent to TS. So what does TR congruent to QS mean? What do you?
bisect.
Abe, what do you think?
I was gonna say that all sides are equal, but
Yeah, but you got to tell me why, though, kiddo. Now, just from this information alone, I think we're good. I'm not 100% sure, but I'm trying to see if someone else is thinking like I am. What did you think?
I think that the diagonals are equal.
And they are.
And that means that
It's
all
100%.
their angles.
Tell me.
The diagonals bisect each other.
The diagonals bisect each other. I'm not sure if that's what that says. Tell me. And they are what? So it has to be a.
Squares.
Well, in a rhombus, are the diagonals congruent?
No.
Do we have the diagonals congruent?
Yes.
True. So this is what I'm trying to tell you now. All right. I don't even think this is really a proof after I'm thinking about it, right? Because this is why it's important to understand everything, so I don't have to go through a big long proof here. Because we know, we prove that the diagonals of what two shapes are congruent? Square and a rectangle. If the diagonals are congruent, it has to be a square or a rectangle. Then, if the diagonals are perpendicular, it has to be a square or a, no, it has to be a square or a rhombus. Do we agree? Right? But when you have a rhombus, are the diagonals necessarily perpendicular? No. So because the diagonals are both what? Congruent and what? It has to be a what? It has to be a square. Do I agree with that? All right. So in this case, I would say that we could just write down in here the diagonals. I'm not going to write it because you can type it in if you want. Sometimes I think that's even better. All right, to help remind yourself, or you can write it. I don't really care. I'm not writing it. The diagonals are both congruent and perpendicular. And if the diagonals are both congruent and perpendicular, then the parallelogram is a square. I don't think that was that bad. One more time. If the parallelogram has congruent diagonals and the diagonals are perpendicular to each other, then it's automatically a square. All right, let's see what's next. All right, I think you guys can do these last 6. All right, why don't you guys try them? All right. What I will do is, I don't think I posted the solutions today. Yeah, so I'm gonna load up the solutions, and you guys can check. But again, guys, I want you to try it. All right, and I don't mind you guys talking to each other. All right, I just don't want you to just listen to what somebody else says and just write down the answer. You got to think about it yourself. All right, we'll knock those out. That's it.